So good morning, ladies and gentlemen. Welcome at today on the GPU Day. With excellent events year by year in the past years. First, let me introduce myself and our company a little bit. Silicon Computers is an almost 25-year-old company. We started our activity in 1995 as a SGI, Silicon Graphics partner and distributor in Hungary. Since that time, we kept our activity on the HPC market, and we had several nice big projects in Hungary at supercomputing centers and academic research and university departments. So just one thing, probably you know or not, I don't know exactly, that SGI, as a leader of the supercomputing market, world leader, merged to HPA 2 years ago, and the SGI HPC technology became the HPC business unit of HPA. So we could continue our activity with the same technology inside the HPA organization, and I'm really happy that we can talk about the new features, the new development of the high performance technology based on SGI technology inside HPE organization. So let's see a past a little bit. Probably you know the top 500, the list of the most powerful public high performance computing infrastructures in the world. And the history is that in the past around 20 years, in every four or 5 years, the performance of the high performance computers was more and more about 10 times. But nowadays, here you can see that this linear increasing has a little bit slowed down, and nowadays the highest performance computers on the top 500 is almost the same or very similar that was about 10 years ago. So something happened in the past because this linear increasing has slowed down a little bit. But we expect for some reasons that this performance increase will continue, and the performance on the high performance computing will be increased again. So you see that the title of my presentation is Head to the Exascale. What does it mean? What does it mean, the exascale, at this moment? The exascale means such high-performance computers then can reach or more than 1 exaflops computing performance. So probably you are not really day by day dealing with this really very high-performing computing infrastructures, but I'd like to show you the current top 10 in the top 500. At this moment, the highest performing computer, the first one is about 150 petaflops, and the 10th one is about 20 petaflops. And we are talking now about exascale, exaflops computing performance in the near future. It's a huge big jump from now until the exascale. It means that comparing to the highest computing, that means 10 times more performance, and comparing to the tens, it means 100 times performance. And this is just the really peak of the performance in the world now. So the question is that where and how can we use the high performance computing, and how it will change our life in the different kinds of industry segments. Here are some examples which kind of industry segments use even traditionally high performance computing. For a very long time, the weather forecast was and is one of the most computer consuming industry segment, and nowadays, you know, the climate research and the weather forecast seems to be more and more important for our life, and that's why the more accurate, more models and higher performing, high performance infrastructure will be more and more interesting and important. And there are several other kinds of industry segments, including the energy or the life science, and traditionally the manufacturing also a user for the high performance computing. Here are the rest on top of some examples. Here are some others that probably you know. These are mostly traditional HPC users, and some of them is important and working in Hungary as well. So let's see the main trends that will hopefully or change the world of the whole HPC market and technology. We have seen that there was a boring period in the past 10 years because the HPC, the demand for the real increasing HPC performance was not really high demand, but we've seen from the recent past some very interesting new important areas. One of them is that the HPC can generate significant revenue and profit on the financial market and profit-oriented area. I will show you something, and the second one, as a driver for even higher performing computer, are new areas like the artificial intelligence and its subsystem, the machine learning and deep learning. So a little bit more detailed. What did I mean? These slides show a very interesting and very important trends and figures that is driving the development of the high performance technology. Each invested dollar can generate additional revenue, around $800 or $600 profit in this investment. So the high performance computing is not only a tool for the scientific researchers, but from the recent past, it is a really profit generated and revenue generated tool for the industry. And this is one segment, the financial services, oil and gas, life science, manufacturing, also all of them can generate this kind of additional value and revenue and profit. And this was the basis of the economical research from the recent past. So it's if the profit-oriented industry or companies needs even higher performing computer and more high HPC technology, in this case, the HPC technology will be developed more fastly. As I mentioned, the new fields of the HPC is the artificial intelligence, and especially the machine learning, and inside the machine learning and deep learning part. I will have some more details about them, but it is important to understand that something new happened in the past that needs more computing performance, and especially the deep learning that can run very well on the GPU technologies drives even the GPU development as well. So, and the first part of the trend was about the demand side, and the second part is how can we achieve this requirement, and what kind of technology improvement are needed for achieving and for serving this kind of requirement. My first slides, or one of the first slides, presented that the 10 times or 1 times more performance comparing to the top 500 machines means a very big jump from the point of the performance, and this is not possible to do just with adding new nodes to the existing architectures and computers. So that's why several new development are required to achieve the exaflops computing performance, and it has several different small steps, starting with the Exascale architecture and the computing devices, especially the GPUs, the bandwidths between or among all kinds of components, either the computing devices and memory, or among the nodes as well, because not only the computing device performance is the major components in the increasing performance, but all kinds of communication side is already important. Always we talk about the different kinds of components of the HPC technology that can allow a higher performance, effective performance, or has a bottleneck in the increasing. So here are, for example, some parts of the technology that needs to be developed for reaching the exaflops performance. The architecture, the Exascale architecture needs not only hardware, but software. From software side, it should be developed, should be improved to give or to make the server performance, effective performance, really high performing, and the increase of the hardware will be really effective for the performance increase. There are some new technologies like Gen Z. If you already have it or heard it, that's fine. If not, you will you will hear about it in the near future. This is a new communication standard is under development now that will increase the communications among all kinds of components between the CPU and memory, but among the nodes as well. It's more performing, and a new standard will be in the near future. The networking is also a very important thing, because we are talking about tens of thousands nodes if we would like to reach the exascale performance. So that's why the networking will be very important. And what kind of connections can we set up among so many nodes? The footprint of such a big machines is really huge and large, and between the nodes the distance is much longer than now and than we can expect, and it's not possible to operate it on the traditional wired communication. So the optical communication, the optical fiber communication will be needed, and this optical interconnect will be the future, will be the part of the node inter-node communication. And of course, the I/O subsystem that can reach the storage part will be a new technology. We'll have a new technology. So let's speak about first about the CPUs, about the processor side. I remember that around 10 years ago, even the AMD and Intel were competing very much on the high-performance computing market, but in the past years, AMD left this market segment, and Intel became the single player for the CPUs. Nowadays, it is changing. It is changing a lot, because AMD get back again into the game, and AMD tried to develop some nice new technologies dedicated for HPC, like the high bandwidth memory technology or the system on chip technology that intend to make the system system components much closer. So that means that the communication between the components became much faster, less latency, and with higher bandwidth. So this is the way where the AMD try to get back to the HPC market. There are some other players. ARM is also a new initiative that is also coming up in the HPC market, and some others. But I would like to highlight this logo, because it's a very interesting new initiatives inside the European Union. So we as a European Union would like to develop our own high performance and low latency and low power consumption CPU in the near future. So we will see what will happen with this initiative, but this is already published, and will, for us at least, it will be very interesting and important. Just some words about the technology, how was evolving. in the past, in every second year, it is the Intel. In the past, in every second year, a complete new technology was published inside from Intel, and nowadays we are at the 14 nanometer technology, processor technology, and somehow this development and the next technology step delayed, and nowadays we are here already, but it was the next 10 nanometer technology was promised by 17, but at this moment we haven't received it, or we will receive it in very short time. The new 10 nanometer technology, new Intel CPU, but at the Far East, the Taiwan Semiconductor has already have 7 nanometer technology. So not we in Europe or the States, but many other companies, especially at the Far East, has new technologies in the CPU from CPU point of view, and that means that everywhere in the world the drive is very, and the competition is very high on the performance, CPU performance. And this is just a short slide on when will be available the really next CPU technology from Intel. We are still now this one, and the 10 nanometer technology will be available at the end of the next year. So the good news, as I mentioned, that the HPC industry is again growing fast, or at least we are expecting it. Some reasons are I already mentioned, and from the industry point of view, it's interesting that in the past year the average revenue growth was about 5%, but we expect in the next couple of years 10 or 15% growth on this market. That means that the requirement for the high performance computing is increasing, and this is an important thing, that mainly the really highest performing exascale performing computers will be required in the world very widely. So let's talk about a little bit the drivers. What is behind of this requirement? There are some components that requires more performance. We don't talk about the traditional HPC things like the traditional weather forecast or something else, but the data, the increasing amount of data needs some special processing procedures and tools, because in the past the most of the data is generated by hand, manually by the users and people, and nowadays a huge amount of data is coming from the technology, from IoT, from sensor, from log file, from everywhere, and this huge amount of data need to be processed somehow, and it takes computing performance. The second one is the algorithm. The algorithm that is called artificial intelligence, and especially the deep learning, that uses the huge amount of data for teaching the computer itself, the algorithm, the digital neural network itself, and this is require additional computing performance. And the algorithms, the big data, and the new GPU technology can solve and can drive the technology. So just one example from the deep learning. You can read several similar stories on the internet, but I'd like to just highlight one thing. This is a hurricane detector that was developed in deep learning way. And the story was that this neural network algorithm has been taught with several hundreds or thousands of images, such images that includes hurricane and doesn't include hurricane. And the algorithm could teach what does it mean that a hurricane will be evolving at a given area. And finally, this algorithm that wasn't coded manually, just was learned from the images, could predict or could estimate the hurricane from new images, from new image sequences. So it's a nice example that for very complex things, already nowadays it's easier to use the deep learning algorithm than writing the code manually. So let's go on from the HPE point of view, how we see the world. This statistics was in 1916 when HPE merged the SGI, and at that time already the HPE became the world leader in the HPC market. And in the springtime, it was announced that HPC acquired Cray, the highest performing computer producers in the world, and now the Cray became the HPC part of the HPE Hewlett-Packard Enterprise. There was a story when the Cray and SGI was together in one company, and then later on they split it, and now the HPE merged together these three companies. This is just a short things about that. In HPE portfolio, we have different kinds of technologies and servers for the HPC, from the liquid cool big cluster until big scale-ups shared memory system and the rack formed server versions as well. We have not only hardware for the HPC, but a complete software support for the HPC development, management, and operation as well. The new development is the code name is Badger, that will answer the new challenges from several point of view. Like it will be a very flexible, cost-effective, universal supercomputing that can include several different technology, and this different technology can be changed and can be selected by the user from the real workflow and requirement point of view. This is a very simple but very important slide. The new performance means higher power consuming components like CPUs and GPUs, and it means that the rack power consumption is increasing a lot. Nowadays, we are talking about around 20 kilowatts per rack power consumption, but in the future we will have, and even in our new project, we will have 200 and 250 kilowatt per rack. So it's a huge big jump, and it cannot be cooled on the traditional way, and that's why a very special liquid cooling system will be developed and will be available. Here are some important things that hold the technology. What are the segments that the technology can serve? Either the data, the amount of data, the traffic data, the connectivity, and even the printed circuit board. These are the components that will be built into the new Badger project, and it will be available at the end of this year. I will jump because I would like to show some rack infrastructure as well. Here are the new Exascale architecture in the interconnect. There are two so-called traditional ones. Probably you know them, but this is the third one called Dragonfly. That is the combination of the previous ones and can scale up to extra large systems. And finally, some slides about the new machines, the new rack machines. It will be developed and will be set up in the almost similar to the traditional racks with chassis, and this is a 16 by 16 rack size installation, closing to the Exascale capacity performance. And here are the components. We will have different kinds of nodes, CPU nodes, CPU node with traditional x86 CPUs or ARM CPUs, or CPU plus GPU, different amount of GPUs dedicated for artificial intelligence or just the acceleration of the traditional computing. We have already such system on our traditional, based on our traditional cluster machines, SGI 8600, with huge amount of GPUs at the Tuna project. These new machines will have a very, very special liquid cooling system with fan-less infrastructures, and this water cooling system means that the cooled water, the cooling liquid will go directly to the CPUs and memories and all components that generates high energy. And the last slide. Finally, I would like to mention this new European initiatives, the Europe HPC, because it's something new that the gods at the European Union, our colleague, found that we inside Europe use the high-performance technology, but not our high-performance technology, but the US technology, for example, and several researchers or researcher institutes use the US infrastructure for their own researchers. And that's why a new initiative started. That means that we inside Europe will have development fund for the high performance computing development, and in the near future it's planned to be installed some pre-exascale machines in Europe by the end of next year. So it's a good news, and for these purposes there are a starting budget and it can be done. So if you would like to interested in, you can find the more details on this website. Thank you very much.
Thank you very much.
And I think I try to be in time.
Yeah, exactly. Thank you very much, Tibor.
Thank you for your attention.
So we have short time for questions if you have. I can see no hands. Maybe it was too early before coffee, but actually...
But I will be here, so if you have any question, let me know, please, and I try to answer them.
Actually, I would have a question. So what should be the computing capacity of one of these racks, about 250 kilowatts?
It's a very, very interesting question because it depends on very much on the architecture. How shall we put together the rack? Depending on how many CPUs, what kind of CPU GPU ratio do you install, because it's very, very flexible. But we already sized some nice configuration around one in a given configuration. One rack could be 1 petaflops.
1 petaflop.
But it's just a very, very average things, depending on the number of CPUs and GPUs and other accelerators. So it's very nice. For example, we are planning 1 teraflops per node performance in the new system. So it will be very huge.
So when this will be available in the market?
It will be available at the end of this year. The first such Badger called big machines will be installed at the end of the year or beginning of the next year in Germany at the Stuttgart HPC centers. It's already ordered, and the production is on the way, but it will be a CPU only and AMD CPU only configuration, because the right really high performing GPU that is will be included in the system will be available only in the middle of the next year. So NVIDIA promised the right really high performing GPU that will be the part of the system will be available from the middle of next year. So the first such configuration will be implemented with AMD processors and CPU only configuration.
We hope maybe we can get a little bit of access to try
yeah,
things.
I hope that, for example, the Zoli and from KFU and his staff has a good relationship to the Stuttgart HPC Center, so he will know exactly everything. Not myself as a vendor partner, but from the customer or user part, he will know exactly everything.
Okay, excellent. Thank you very much.
Thank you very much.
If there's no more question, I cannot see, so let's thanks Tibor again.
So if somebody would like to have such a computer for Christmas, under the Christmas tree, let me know, please, because it could be available by that time.
You have to have a big Christmas tree for this thing.
It would be a nice Christmas tree.
Okay, thank you, Tibor.